Today we're going to talk about transformations of quadratics, and this is something that you might want to have two colors for, so either a pen and a pencil or a certain color, whatever you kind of have today, just to make sure that you can see what's happening to the quadratic. So our general form of a quadratic function, one of the forms, there's a bunch, this is probably going to be new to you, it looks like this: f of x equals a parenthesis x minus h squared plus k. And so there's going to be different things that are going to happen to that parabola, and we're going to use that to figure out what actually happens in shifting quadratics. So the first one we're going to look at, you're going to have to make a rough sketch in your notebook. It is not perfect, and that is okay. And I'll give a couple points here and a couple up here. So I'm just putting a couple tick marks on each axis. Now, every transformation starts with the parent function. In quadratics, f of x equals x squared is known as the parent function. If you think about the word parent, parent is where you come from. You come from your parent. So the parent function is where every function starts from. So x squared is what makes it a U shape. So these points, 0, 0, this one is always 1, 0, and negative 1, 0, are always there on the parent function. So whenever we are graphing something and we're trying to figure out what's happening to it, we start with that parent function. So I'm just going to rough sketch. And this is also what we look at to see how it moved. So that's kind of what it looks like. Now, if I have the graph f of x equals x plus 3 being squared, and I want to know what happens to it, okay, if I use my calculator and type it in, x plus 3 squared, and press graph, I'm going to notice now my original vertex was at 0, 0, and it shifted. And if you count, you can kind of see it 1, 2, 3. It went 3 to the left. So in that same color, I'm going to say, okay, 1, 2, 3. So it went here. So then they're all up 1. Okay, up 1, right 1, up 1, left 1. So it kind of shifted like this. So we can say, okay, what happened from the dark green to the light green? Well, it went to the left 3 units. Interesting. Well, if I try maybe with my pink pen, well then what do you think is going to happen if I have x minus 5 squared? And you might already be thinking something, but let's type that one in the calculator. So I'm going to clear the one I had, and I'm going to do x minus 5 squared. And now you could be doing this also on your own with your graphing calculator on your computer. And if I press graph now, remember, parent function starts at 0, 0 at the origin. So now, 1, 2, 3, 4, 5 to the right. So this one went right 5. So instead of being at 0, 0, it went 1, 2, 3, 4, 5. My vertex shifted over 5, and these points still stay. So I get this parabola. So what we can do is we can generalize what happens. Well, what number did I change? Well, I changed it. Here it's minus 5. Here it's plus 3. So I'm really changing the h up here. So what we can say is, if h changes, the graph translates, that means moves, slides, left and right. Now, a little something weird here is if this is plus, so if I see x plus a number, it moves left And if I see x minus a number, it moves right. So that's the first shift you're going to see, and it's a horizontal shift. The second shift we're going to look at, so you're going to draw another quick graph, is going to have another shift happen. And I'm sure some of you are already thinking about the possibilities. So let's go ahead and graph that parent function again. And this time, let's write it over here in the same color, f of x equals x squared. And this time, let's do f of x equals x squared plus 3. And let's have our second one be f of x equals x squared minus 5. Okay, let's see. So you'll notice I use the same numbers, but in here the 3 was inside the parentheses, and now it's just out here. X squared plus 3, graph. Oh, it looks like it moved up. So it was at 0, 0, and it went up. Yep, 1, 2, 3. So this made the graph go up 3. So my vertex will go up 3, and I'd still have these. So it's shifting up. So what do you think is going to happen when it says this? Let's see. X squared minus 5. And most of you, I'm sure, are thinking down, and yep, it is down. 1, 2, 3, 4, 5. So we'll go down 1, 2, 3, 4, 5. And it looks like this. So this that we're changing, the 3 and the 5, was actually the k. So if k changes, the graph translates or shifts up and down. Oops, sorry, couldn't see that. So if k changes, the graph translates up and down. So if it's plus 3, it moves up. And if it's minus any number, it moves down. So now if I go back to the original equation, we now realize what the h and the k is, but we didn't really get to talk about the a. Now the a has 2 special things that will change the graph. And each of those things are quite simple, so sometimes the shift is missed. So the original parent function still looks the same, but what will happen sometimes is you will have a graph that has a number in front of the x. So the a is a number bigger than 1. So for example, if it was 3x squared. And then on the other side, you'll have things where there's a fraction. So instead of a bigger than 1 and being 3, it'll be something like 1/2 x squared. And these are kind of hard to see. So what I'm going to do is I'm going to put in the parent function this time and then put in 3x squared. And let's make our parent or our new one be a darker line so we can see the difference. So there's the parent function, and there's the y equals 3x squared. So what you're going to notice is this graph, it got narrow and it starts rising faster because it's saying triple this, make this grow faster. So what essentially happens is it's kind of hard to graph, but everything triples. So instead of being at 1, it's at 3. So it's going to go kind of inside. So that means the bigger the number, the narrower and more stretched it is. So this made it narrow and it stretched it up. Right? It's like pulling like a rubber band up. So I'm going to do the same thing, and instead I'm going to leave the x squared and I'm going to change this now to 1/2. So remember, if you do alpha y equals 1/2 x squared. So let's see. So there's our parent, and here is our other one. And actually, let me make it darker so you can see it. So here's what happens when you do 1/2. So now what happened is it got like wider, right? It's opening up more. So it's kind of flattening. So in this case, it's becoming wider. And it's really stretching to the sides. Some people will say like flattening. So instead, it's like taking half of everything. So it's wide like this. And it's kind of flattening down. So our general rule of thumb for the A value here is if the A is greater than 1, it's going to make it narrow and tall. Sometimes you'll see skinny, right? That's the one, the light green one that's inside. If A is less than 1, like a fraction, it's going to make it wider and you'll see flattened because it's going to open up wide. This is like creepy guy smile. This is like normal smile. So there's one part of A. Now the last part of A, I think, is the easiest one to remember. So remember, here's our parent. Now the only other thing that they can do is they can do this. Y equals negative x squared. And negative, what that's going to do, okay, and we'll do the same thing, leave that one. Negative x squared, and let's make it darker so you can see it. Let's see. Here's the parent, and here's the other one. Boom. What did it do? It just took it and it flipped it over that x-axis. So if A is negative, it's going to flip remember we call that a parabola, that's the shape of it, over the x-axis. So it's going to go like this, stay here, but these ones are going to come negative now. So it's going to flip like that. So really those are only 4 things. The graph can move left, right. The graph can move up, down. It can get narrower or wider, and it can flip. This is really all about recognizing and remembering which does what.